Ultimately, lots of diagnostic tests, they're looking for technologies that can be used in the field. And let's say in the sort of agricultural setting, we always call that pen-side. So recombinase polymerase amplification, because of its properties, because of the fact that it can be stored at room temperature and dried and is portable, makes it a good option for us to look at that sort of technology.
Bovine TB is very, very political. It's highly charged, very emotive disease, especially in the UK. When a cow goes down with TB, they have to be culled, they have to be removed from the herd. That herd is also then locked down for a certain amount of time, and that can be a big financial drain on the farmer, on the government taxpayer. The current diagnostics are based on a skin test, which is over 80 years old. So what I've been trying to develop is a novel way and a quicker way of detecting these mycobacteria. And so how I do that is using these organisms called bacteriophage. They're just little viruses that only infect mycobacteria, and the bacteriophage I use is called D29.
The blood is the blood. We extract the mycobacteria from it, we use the phage to find the cells and to break them open, show that they're alive, and then we change the primer targets and it tells us which mycobacteria we've got.
The bedrock of all my research is based on this platform technology, using the phage to go in, replicate and lyse out, and have a really quick way of detecting the mycobacteria rather than waiting the 12 weeks you have a 24-hour period.
When we started developing a new assay for blood, also with the context of knowing that we wanted this to be portable in the future, we looked at alternative technologies, and say RPA it has this reputation for not being particularly sensitive to inhibitors.
With PCR, with the high temperatures and the cycling of the temperatures, that can break open cells, and we don't want that. We want the phage to break open the cells, and that's why we wanted to move to an isothermal technology. With RPA, I've used it with a gel, so you can get a nice band on a gel, you can see it's the right size, you can cut that band out and sequence it to make sure what you're amplifying is right. You can also use it with the real-time detection with the fluorescent probes. So it's very adaptable, you could use it for lots of different things.
Ultimately, what you really want is the vet to turn up on the day, take the sample, process it through a nice kit, pen-side, tell you on the day what it is that you need to do, either to control the disease or what the fate of this animal is.
You can bring this kit with you, you can plug it into your car, you can be on a field, or you can have it as a standalone test, and you can actually take your samples and do your diagnostic there. Development-wise, we want to shorten all our technology into one tube and have a nice lyophilized RPA reagent down the bottom, and as soon as we put our sample in there, we'll get our detection. We use our technology on a lot of different sample types, so it's not just blood. So whether that be in the dairy, in your beef industry, but also lots of different animals. We've worked with testing sheep, there's problems with camelids and with deer, so there's a lot of things that we can use with this technology. Being able to test all these different sample types is very important, but not being inhibited by them is even more important.